Okay, everyone, now we're going to move on to activity 2. This is going to be looking at the metric system. So let me go ahead and share this. Okay, so now we're going to go into the metric system. I have to warn you guys that math is not my strong suit, and I am a complete cheater when it comes to using the metric system, so bear with me here. I do suggest attending a SGL session for this. Because they will teach you how to properly use it. I just use this like every day, so I tend to conceptualize math because it's not my strong suit. Yeah, so I definitely conceptualize math instead of like working out problems usually. Okay, so the metric system and metric conversions. The metric system is used in nearly all other countries in the world, yet the US continues to use English units. And the metric system is a system of measurement used throughout the world and in the scientific community and or medical field. If you, so here in the US, we tend to think about mass or like our weight in pounds and ounces. If you have family members in Mexico or in other countries, you notice that they use kilograms or grams. Here for distance, if you think about football, we use yards and feet. We also use miles. Distance in other countries would use meters. Volume, we tend to use gallons, quart, cup, and fluid ounces. Volume in other countries is liters. And temperature, we use Fahrenheit. Other countries would use Celsius. In science, we also use the same units that other countries use. We do not use English units. And let me actually put this pointer on laser because it's easier to see. But essentially, this is your base unit. So your base unit would be either grams, meters, or liters. So if you want to talk about 1 meter, for example, and you want to turn that into centimeters, you have to take that meter, times it by 10, times it by 10 to get to centimeters. So if you're moving to the right, you're going to times by 10 each time. If you have 1 meter and you want to talk about kilometers, you would have to divide by 10, or let me take it the other way so it's easier to visualize. Divide by 10, divide by 10, divide by 10. So you divide by 10 3 times. And that's really how this system works. It's really easy to conceptualize. You're working in factors of 10, which is much easier to work with than English units, which the factors tend to change. So we have 12 inches, or no, 12 feet in 1 yard. I don't even know what it is, honestly. We have something in the yard. So why does the metric system matter? I think it's good to kind of have an understanding of how the metric system came to be, why it matters, and this is basically a summary of this TED talk, but we're going to go ahead and watch it just because it's very short. I don't know if I can actually share this. Right? Yeah, I can. Okay, let's see if it works. Okay, so that kind of talks about that. Oh my goodness, I don't know how to pause it now. Let's see. Hold on a second. Bear with me, or else they're gonna. And sorry, I was listening to music videos before this. Okay, now let's go back to the PowerPoint. Okay, so I think that's a good video to kind of show why we use the metric system. And, it kind of shows you how it's based off of real observations and natural observations of Earth and of our surroundings. Growing up, English units were much easier for me to use. I was born and raised here in California, so it's much easier to think of everything in pounds as far as weight. But now that I have approximately 9 years in a laboratory, it is way easier for me to use the metric system. But I do see how a lot of people are used to the English units, so it's kind of a difficult transition for them in the beginning. So your book breaks this down pretty nicely. You have this image here, which shows where your base unit would be. Remember, this would be liters, meters, or grams, depending on what you're measuring, whether it's volume, mass, or distance. So let's just use distance, for example, and we'll put meters here. So your base unit would be meters. Everything up here is going to be a larger unit. So kilometers would be larger than meters. And then everything down here would be smaller. So centimeters are smaller than a meter, and millimeters are smaller than centimeters. And you essentially are moving by 10 each time. So if we kind of take this image and go over here, if our meters is here, remember you're dividing by 10 for this unit here, divide by another 10 for this unit, and then divide by another 10 for this unit. So to go from meters to kilometers, you basically have to divide by 1,000. So 10, 100, 1,000. So if you have meters here and you want to go to millimeters, you essentially have to times by 1,000. So times 10, times 10, times 10. And then if you're given a unit to start off is millimeters and you want to go to micrometers, you have to times by 10 3 times, which is timesing by 1,000. So times 10 times 7 times 10. So 1 millimeter is equal to 1,000 micrometers. So this unit here is micro. It looks like this U with a teardrop, and this unit here is nanometers. So for your purposes in this class, these are the units you need to know, or prefixes, the common prefixes you will be working with. It would be kilometer or kilo, deci, centi, milli, micro, and nano. And yeah, I mean, these are basically the basic ones you will be working with if you were in a lab as well. Specifically kilo, your base unit, milli, micro, and nano on a microscope, really. Okay. So here I give an example. So say we start off with 5,000 meters. What is 5,000 meters in kilometers? So you have to divide 5,000 divide 5,000 by 1,000. So divide by 10, divide by 10, divide by 10. So 5,000 meters is equal to 5 kilometers. If you have 5,000 meters and you want to convert that to millimeters, you have to times by 1,000. So 5,000 times 10 times 10 times 10. So this is 5,000 meters is 5 million millimeters. Yeah. And that's basically how I do it. Like I said, I probably take a lot of shortcuts here, but it works. So here are some examples that we're going to try. So if your base unit is meters and you're starting off here and your first value and the value you're given is 1.6 meters and they want you to convert this to centimeters, you will have to move your decimal point 1, 2, 3 times. So you're going to move it 3 times. 1, 2, 3. Oh, sorry. no, not 3 times, what are we doing? Centimeters, move it twice. So if you are given meters, let's start that again. If you're given 1.68 meters and they want you to convert that to centimeters, you have to move your decimal point over 1 2 times. So you go 1 2 and your answer is 168 centimeters. If you are given, and you could also use this chart here, whatever works for you. If you are given 0.057 kilograms, so now we're over here, and they want you to convert this into grams, you're going to move your decimal point over 1 2 3 times. So we're going to go 1 2 3. And it's going to be 57 grams. So here you just have to be aware of where you're moving your decimal point, whether it's to the left or to the right. And this is why I say I kind of conceptualize math a lot. I just know that meters is a larger value than centimeters. So if you have 1 meter, you're going to have a lot more centimeters in to make up that meter. And so forth. So go ahead and work these out on your own. Hopefully you come up with the same conclusions. And that is basically how to do conversions with metric system.